Hello, Algebra 2 students. I'm here with the answers to, or help for, the lab staff problem that I asked you to do yesterday. So let's look at that. This is a linear programming problem. This is used to maximize or minimize some quantity like cost or profit. Somebody the other day had asked for a real world use. When are we ever going to use this? This is one time when this linear programming or system of inequalities is used. So you had this problem that says lab staff. And if you remember that military rations problem, what we did was take each bullet point or each restriction, or they're called constraints. It's each one of those bullet points, and we're going to write an inequality for those. So what do we have here? It says the local university has received a grant to open up a laboratory for scientific research. The grant will fund the use of a certain amount of building space on the university grounds, as well as salaried positions for each of the research teams, scientists, and assistants. However, the grant does have certain restrictions. The research team can only include up to 30 staff members, so there's an important piece of information. Let's define some variables. Let's let X be the number of scientists. And let's let Y be the number of assistants. So if we know that the research team can only include up to 30 staff members, so then we would have X plus Y, scientists and assistants, up to 30. So what does that mean? Let's think about that. Can it be 25? Can it be 20? Yes, it could be because it's up to 30. Can it be 30 exactly? Yes. Could it be 31 or 32? No, because it says may include up to 30. So I'm going to put less than or equal to. Let's come over here and do, what are these words? We did up to would be less than or equal to. Okay, the next bullet point says the staff must include at least 4 scientists. Think about your variables. We have X for scientists, X for the number of scientists, Y for the number of assistants. This bullet point doesn't say anything about assistants. All it says is scientists, at least 4. So we'd have X and 4, at least 4. So can they have 3 or 2? No. Can they have 5 or 6 or 4? Yes. At least greater than or equal to. Okay, what's next? It says the number of assistants must be at least half the number of scientists. The number of assistants, that's Y, must be at least half the number of scientists. At least. Oh, at least is greater than or equal to. Then we have one more. It says each scientist requires 400 square feet of workspace. Each assistant requires 100 square feet of workspace. And the university has 7,200 square feet. So how much does each scientist require? 400x, and each assistant requires 100y. And the university has 7,200. So if we're designing this lab, can we go over 7,200? No, because that's all that are allowed in that. That's all that building has. We could go less than, we could go equal to, but we can't go over. All right, so here are your inequalities. Okay. You would graph these. You could solve them for Y and graph by hand, or you could use Desmos. Okay. I'm looking for my paper. Give me a second. There it is. Okay. So if you want to, you could solve these for Y. That first one, we would subtract the X and go Y is less than or equal to 30 minus X. The second one only has an X. The third one already has solved for Y. And then that one we would have to subtract. But you know what? Desmos, we can graph without solving. Let's use our technology. So I'm going to go here to this new tab and type in desmos.com or Eduphoria. Eduphoria will not help us with this problem. Okay, graphing calculator. Now, get this iPad off my neck. That probably doesn't look good. Okay, the first inequality we had was x plus y is less than or equal to 30. All right, let's see, x, oh, not equal to, plus y. Your little keyboard down here has all your little symbols, less than or equal to 30. Okay, next inequality was x is greater than or equal to 4. That's going to be a vertical line where x is 4. Next, y is greater than or equal to 1/2 x. Be sure you get out of that fraction and put your x over there. And then the last one is 400x plus 100y, because each scientist requires 400 feet, each assistant requires 100 square feet of workspace, less than or equal to 7,200. Okay. Now, what are we looking for? We are looking for the part of this graph that's shaded for all. So it's not the green part. It's not this green part over here. Whoa, I don't want it to move. Sorry, it's probably making you dizzy. I've lost it. Got all my inequalities there. Okay. All right. So let's see if I can show you. Maybe I can do it this way. Every time I try to point on that, it moves it around. I don't want it to move around. Okay. So do you notice that it's the part that's shaded for all is this part right here? Okay, it's a little four-sided part, a little quadrilateral looking thing. Okay. So what did we do with the military rations one? We found the vertices. Vertices is plural of vertex, and it's a corner. So with Desmos, I can click on this corner or this vertex, and that is the point 426. And I can point on this one, and that's 1416. And this one is 16.8. And this one is 4.2. So there are my boundaries, or my vertices of this. It's called a feasible region. Okay, so these are the corners. Now, how is this going to work with, what is my question asking? Have we lost the question? The question says the annual salary scale mandated by the grant is $45,000 for a scientist and $29,000 for an assistant. Determine the maximum and minimum amounts needed to budget for salaries in the research team. So what do these points mean? When I have this point 426, that means 4 scientists. Sorry, you cannot see that color. This means 4, remember X, so scientists, and 26 assistants. So if I'm going to do that salary, each scientist has a salary of $45,000. And each assistant, and there are 26 of those boogers, $29,000. And if you do that math, you get 4 and 26 is $934,000. Okay. So then we need to do that with each one of those vertices, and then we'll take those big numbers at the end and find out which one's the minimum, which one's the maximum. So what other one do we have? We have 14, 16. That means 14 scientists and 16 assistants. You have to be careful how you abbreviate assistant. Okay, so then we have 14 times 45,000 plus 26. Nope, sorry, not 26, 14, 16 times 29,000. Multiplying the number of scientists times the salary, number of assistants times the salary. And for 14, 16, we get 1,094,000. Okay. You would do the same thing with 16.8, and you would get 952,000. And you do the same thing for 4.2, and you would get $238,000. This turns out to be your minimum because that's the lowest. What are we looking at? This number, this number, this number, and that number. 238,000 is your minimum. 1,094,000 is your maximum. What did we do? Let's go back to our paper if I can find it. Take this off. Okay. We took each bullet point and wrote an inequality. Then we went to Desmos and we graphed it. And we used these points, plug this in for the X, use this for the X, this for the Y, and put that with those salary numbers from the problem and found our minimum and maximum. Okay. All right. See you in the next video.